Okay, so Math 2400, Lecture 10, Random Variable 7, Poisson distribution. Well, let's start with an example. So suppose a bank has come up with the following estimate. Lambda equals number of customers arriving per hour. So you can do that either by something that counts the number of customers, or just put somebody over there, count the number of people entering the bank. But anyway, so they have come up with this number. Lambda is the number of customers getting into the bank per hour. Then, in order to do some, say, planning, I don't know, maybe on how many, say, people should work in the bank at certain hour or certain days of the week, for example, we let X be the number of customers arriving in a time period of T. So if this is the average per hour, the average per the time period of T is lambda T. So in fact, lambda T is average per in that period of time, the period of time of T, right? So this is like lambda divided by T. So when you multiply it by T, you will get the number. So that's the average number arriving in a time period of T. So if X is this random variable, then probability that X is X, and this is an integer, right? So you don't say 2.5 customers. You just have an integer here starting at 0, and that is this, e to the power minus lambda t times this lambda t to the power x over x factorial. And x starts at 0, x is 0, 1, 2, dot, dot, dot. Okay. Now, if we just concentrate on 1 hour, this will be just lambda. So you might have seen this as a lambda. And so let me give you a simple example here. So Poisson is, when we say X is Poisson, it has one parameter, lambda. So example is, suppose 5 from 10 to 12. So we can ask a question like this. Suppose we know that the 5 people in average arrive at a bank per hour. What is the probability that 10 customers arrive next Tuesday from 10 to 12? Okay, so let's write down what we have here. Lambda is 5. The time period is 2, right? 12 minus 10 is 2. And it's asking for x, well, not just x, p of x equals, how many did I say? 10? 10. P of x is 10. Well, since I'm assuming that this average is for every day, if the bank has different averages for different days of the week, then go with that. So if the average for Tuesday is like 2, then go with 2. So since it doesn't say anything, I can just assume that this average 5 is for every day of the week. Okay, so I need this. P of x equals 10 will be e to power minus lambda minus 5 times 2, and this is 10 to power how many? Oh, gee. Well, let's do something so it doesn't, they are not the same numbers. So let's say 15 customers, okay? So you don't get confused what's going on. 15 customers. So 10 to power 15 over 15 factorial. Okay. So well, 10 to power 15 is huge. That's 1, 0, 0, 0, 0, 15 zeros. But e to power minus 10 is also a very small number. So, and also it's divided by 15 factorial. I don't have a calculator again to calculate this thing for you, but this will give you some probability. Well, it should be very small. And why I'm saying it's small, because the average is 5. Now, in 2 hours, the average will be 10. And I'm just asking for 5 more. So it's like for 3 hours. But anyway, so it's that simple. So now what is the expected value? So if I have x is Poisson lambda, so I go with that. It's interesting that both expected value or mean is in fact lambda, and the variance of x is also lambda. Both need some calculation, which I'm not going to do, but those are in fact the two things related to Poisson distribution. That's all for Poisson. And next lecture I will give you some other ideas about Poisson distribution and in fact Poisson say process, which is a stochastic process. Okay.